In this lesson, you are going to understand the concept of time series modeling. By the end of this lesson, you will be able to explain time series analysis, build time series models using ARIMA. So let's go. Time series models are useful models when you have serially correlated data. Time series can be defined as a set of measurements of a certain variable made at regular time intervals. Time acts as an independent variable for estimation. A time series is defined by the values y1, y2, y3, and so on of a variable y at time t1, t2, t3, and so on. This is given by the equation y equals to function of t. Where can you apply time series modeling? Time series modeling can be applied to any dataset that includes time, such as daily sales score of e-commerce, monthly production of a shoe manufacturing company, monthly tickets sold by an airline, and yearly GDP of a developing country. Notice that all these datasets include time. Time series models have been found to be one of the most effective methods of forecasting decisions that involve factor of uncertainty of the future. Most often, the future course of decisions and actions for such processes will depend on what the anticipated result would be. The need of these anticipated results has encouraged organizations to develop forecasting techniques to be better prepared to face the seemingly uncertain future. Also, these models can be combined with other data mining techniques to help understand the behavior of the data and to be able to predict future trends and patterns in data behavior. Here, the predictive model defines the likelihood or cluster ID, or a better representation of unlabeled data. What is the need for time series modeling? Time series modeling is important when there is a need to understand the seasonal patterns and evaluate the current progress, and also when you need to do future forecasting. Forecasting involves the models that fit the historical data and use them to forecast future observations. It is also helpful in detecting unusual events. Time series pattern types Part A. Let's understand time series pattern types. Trend is an example of time series pattern. A trend is a long-term increase or decrease in time series data. The best example for a trend can be a stock trend that is largely based on public sentiment, novelty, and the demand for different products and services. In the stock market, a trend can occur either in the market at large, with individual stocks, or both. Generally, a trend moves up or down until something alters and changes the trajectory. A trend can be either uptrend or downtrend. Uptrend describes when sales is moving upward or getting higher. An uptrend is characterized by the chart's peaks and troughs reaching new highs as the trend progresses. So if you look at the chart over time, it may be zigzagging, but it's generally going up. Downtrend. As you probably already guessed, a downtrend is the opposite of an uptrend. It's when a stock price is moving downward or getting lower. The downtrend is characterized similarly to an uptrend, but in the opposite direction. The troughs and peaks in the chart continue to drop as the trend keeps moving. The chart's general direction is down. However, over time, it may zigzag just like the uptrend. Another example of a time series pattern is seasonal pattern. A seasonal pattern exists when a series is dependent on seasonal factors such as day of the week, month, or quarter of the year. Seasonality is always the measure of a fixed and known period. Thus, seasonal time series are also called periodic time series. The graph plot shows the famous Canadian lynx data. The number of lynx trapped each year in the Mackenzie River district of northwest Canada from year 1821 to 1934. It clearly shows a periodic population cycle of 10 years. The cycles are not of a fixed length. Some last 8 or 9 years and others last longer than 10 years. Time series pattern types Part B. The next example of a time series pattern is a cyclic pattern. A cyclic pattern exists when data exhibits rises and falls that are not of a fixed period. These fluctuations usually have a duration of at least 2 years. Think of business cycles that generally last several years, where the length of the current cycle is unknown beforehand. The graph plot shows the monthly sales of new one-family houses sold in the USA, 1975 through 1995. There is strong seasonality within each year, as well as some strong cyclic behavior with a period of about 6 to 10 years. The fourth example of a time series pattern is an irregular pattern. The irregular component of a time series is the residual component after the trend cycle and the seasonal components have been removed. It corresponds to the high-frequency fluctuations of the series. Short-term fluctuations in a series that are not systematic and not predictable give a result as an irregular component. The best example for this would be uncharacteristic weather patterns. Now let's understand what white noise is. A white noise series is one with a zero mean, a constant variable, and no correlation between its values at different times. This means that all variables have the same variance, and each value has a zero correlation with all the other values in the series. If your time series is white noise, then you cannot reasonably model it and make predictions. In other words, since values are uncorrelated, the adjacent values do not help to forecast future values. So how does white noise affect forecasting? If the data set has white noise, time series analysis cannot be applied. If the data set does not have any white noise features, the time series analysis can be applied. As shown in the graph, the data points present cannot be used for forecasting as it also contains white noise features. An example for this could be the stock price of companies that may vary daily, and the time series analysis becomes uncorrelated. Let's now understand what stationarity is. Stationarity